Hi, I'm Eric, and this is Mark, my buddy. We're in Wisconsin. We're at what we affectionately call Pounding Camp. And Mark is going to give you a walkthrough on the machine that he has been building, and we've worked out the bugs over, what, 5 years now?
About 5 years now.
About 5 years. So basically the video is being made so that anybody else wants to make one, here's some information on how the machine works and how it's put together if you'd like to build one. So go for it, Mark.
Okay, so kind of an automated power hammer to pound the black ash that we've been harvesting. Been getting a lot of hand and nerve issues by pounding by hand, so we look to try to speed things up a little bit and automate it. So we started out with the concept of using a breaker hammer because it has a frequency of hammering about 300 beats per minute, so that it's a lot faster than you can do it by hand. The problem is then, how do you hold this thing and keep it stable enough as you pound a billet of ash? And one example of a billet is one like this that we've cut out of an ash tree. And this one's got relatively thick growth rings, but we'll show you how to do that in another video. But basically what we're trying to do is use this hammer head to pound on the ash just like we would if we were pounding with the back of an axe. So it's coming down and hitting the ash, rapid beats, and within 10 minutes or so we can usually get a billet like this pounded out and separated to good usable weaving material. So the hammer needs to be held in place, and I built a platen off this frame. It's similar to what I would consider like a guillotine frame, so that we've got this upright frame, and on the frame we've got a platen that slides up and down. So I've got a winch on here that can raise and lower the hammer. So that was just a fabrication of wood and some clamps on the front to hold it in place. Zip tied the switch to an on position, and then we're using an on-off foot switch to power it on or off. And so that's where it's wired direct, and then we've got the lift driven by the hoist. The hoist is bolted to the back, and what we built the H frame on was a Harbor Freight shop press. I believe it was a 200-pound shop press. Did not use the middle, but we used the frame, and we added 2x4s to the U-channels on the side to extend it up. We put a cross brace on the front and the back, bolted those in, and then allowed a place to put a center pin for our hoist. So the hoist is bolted to the floor on a 4x4, goes up through one pulley, through a second pulley, and that's what raises and lowers the head. So here you can see as it jogs up and jogs down. So that's just the box that's sitting on top. We did have to put some guide rails on the inside edge to kind of stabilize it. So did that top and bottom. The outside frame blocks are just 2x6s, and those are cut, and so it's large enough to give a little space, and so there's friction, not a lot of friction to it. I did wax the 2x4s where it's sliding to help it glide, a little lubrication.
We'll talk about the most important part.
About
this
about the
base and the guides.
Yeah, the base and the guides. When we started out, we just had a stump from a maple tree, and it didn't last long. We figured we needed more mass, and so similar to the metal pounding power hammers, we needed an anvil, so I built one out of 4x4 using 4x4 posts, cut them off and ready rod and bolted it into one mass. On that, because this sits outside, we didn't want water getting into the top of it, so I did put a cutting board, high density polyethylene on top, just to keep water to getting in from the end grain. And then after a few experiments, we decided to go with a 1/2-inch steel plate that I had fabricated at a machine shop for the hole locations. And I have inserts into the anvil, and that's held down by these 3 thumb screws. And then we put on roller skate or skateboard wheels to keep a spacing of about 1.5 inches. So when our billets would slide through, they're not always square to the outside edge of the bark like this one. So sometimes they're at an angle, and that's going to want to just kind of bend over, torque over as it's pounding. So as we go through and in the pounding cycle, the wheels let you kind of support the ash billet as it goes through the pounder, like that. And then with this, we're limiting our width of our splint that we have to cut to that 1.5 inch range. So that's as far as
keeping it in control from getting off,
yeah,
out of line,
moving out of a line with this.
And the other cutting board with the groove in it. Explain why we developed that.
So we didn't want to be in contact directly with the ash onto the metal because of the rust issue, and we didn't want discoloration. So we wanted something that would help the wood glide through. If there happened to be a knot on the backside or something was a little rough, we wanted it to slide through easy. So we put, this is a high density polyethylene cutting board as well. It's just fabricated with the hold down holes through for the skateboard wheels, and then a slot that's open all the way through. And when the hammer comes down and pounds, the ash will flex a little bit. And so what we found in the growth rings, that helps break those cells in that spring growth ring to separate. And so in some of the videos you'll see, you can see the dust flying apart when we pound. And again, this is a lot easier
because
than,
it bends right at that groove.
right. And if you watch any traditional ash makers or processors, a lot of times when they're pounding it, they might take it over the edge and pound the end to get it to flex. So that's what this is doing, is allowing it to flex.
And did you do anything to the bit that you're?
Oh, certainly. When we first got the power hammer, we were trying to figure out what kind of a hammer could we hit that would be flat to simulate the back of an axe blade. And we tried weldments and heat treatment, and we tried, I think, about 5 or 6 different variations, and the welds would break. The impact, frequency, and shock value just wouldn't allow it to survive. So what we did is we bought a wide chisel for the jackhammer, and then we took it to a machine shop that did water jet cutting. And so in this process, they just cut it off flat, and then we ground the edge a little bit just to give it a little bit of rounding. And I can pull it out and show you what that looks like. So this was normally a chisel bit, extended out another 1.5 to 2 inches and tapered down to the chisel point. But now, once it's been water jet cut, it's got a flat edge, and that's what we're using to pound the ash. We have to increment then step by step across the ash billet as we feed it through.
Looks like it's been doing some work.
Yeah. It's not quite as rusty here as...
Well, Well, great. That should help everybody out a little bit. I think we kind of went through the basics of the tool, and future videos will just walk you through actual making of the billets and everything that we learned going into prepping the materials for this particular machine. So until next time, it's Eric and Mark. Bye.